Would introduce you now the next speaker, Ulrich Kröner. He's working at TAXUD as head of sector of enterprise architecture. He's responsible for the evolution of EU customs and taxation IT platforms. These platforms connect member states, third countries, private companies, and the Commission. He's been involved in IT throughout his career, and he has worked 11 years in the private sector as a consultant and developer. His past assignments include 5 years in IT security policy and advice, and he has also 9 years of experience as an IT manager. I will ask now Ulrich to present us how the data, or how e-archiving has dealt with taxation and customs data.
Okay, thank you very much for this introduction. Yes, I'm one of these IT people that occasionally ask archival people to throw data away. I don't know quite a lot about the archival domain, so as my colleague mentioned, I've been active in IT throughout my career. So I work in TAXUD B, which is an IT directorate inside of TAXUD, which works on taxation, excise, and customs as well. So for the European Customs Union. And inside of that little IT directorate, sort of a mini digit, if you like, I'm in charge of one of the sectors that deals with architecture, which is transversal. So we often like to call ourselves business agnostic. We however have our own business, which is to manage the different IT platforms, as was just pointed out. So next, what I'm going to be talking about is our specific quote business unquote need, what we had as a need, what sort of challenges we had specifically regarding archival, and how these are being addressed by the e-archiving CEF building block that we've chosen, and a little bit about our ongoing project in terms of execution and planning, and where we want to go from here, basically. So, what is our business need? We have a magnificent new system, the ICS2 system. Stands for, and sorry, TAXUD is a bit all about alphabet soup, Import Control System 2. What this is, it's a system for importing parcels and, generally speaking, goods into the European Union Customs Union. So imagine that the year is 2023, it's after the go-live, and you buy a parcel from Amazon United States, and it gets shipped to Europe. Normally, your book should then be registered in that system inside of an XML message, which should go into from the economic operator into your particular towards us, basically, over an XML message, which will be ingested by the TAXUD access point for AS4. AS4 is a particular profile of CEF e-delivery, another building block, and it will then be taken on board by the access point for AS4, which we named the TAPAS because we like acronyms. It will be a signed message. It will come with its own certificate chain in the message, and it will have used TLS to actually obfuscate the data so as to not make it readable by just everyone over the internet. We will have a very high volume of very small message, and we have a need for archival every day. Keep our messages for 10 years, and we will have we can have millions of messages per day, and indeed later on this is what exactly is predicted to happen. And we also need to archive our audit and logging records for about 7 years. We are in the lucky case here that we've got structural data, meaning XML data in an Oracle database. Later on, we'll have a different system which will also have archival needs, which is the Common Communications Network 2, I mean CCN2, for those who have been working in the customs domain, may be familiar with that sort of acronym. It's the service-oriented architecture edition of something that connects member states and between themselves, and also with DG TAXUD and other DGs in the Commission. Okay. What were our objectives? We need to store our data sets, which are these messages that are CEF eArchive AS4 formatted messages together with their contents. together with the associated set of metadata. So typically in messaging, you got the originator, the recipient, the date, the ID, and then possibly some other fields as well. Then we need to retrieve these archived records very sporadically. It's not like the previous speaker has pointed out, where there's lots of reproduction going on. Our use case is that the economic operators and member states may disagree at some point, saying, okay, no, I sent a message, and the member state says, no, but we did not receive it. And then what happens is that the member state and the economic operators do a search in their systems, try to find if the message actually exists, and if not, they come to us and ask our help desk via ticketing, how about this message? Did you, DG TAXUD, get the message? And if so, can you reproduce the message, please? So we are going to have very few and far in between service calls that we anticipate for this sort of thing. And then we want to make it as generic as possible. We want to also make the archival and retrieval secure. So we will have certain access rights defined into the retrieval system as well. Basically, our archive goes from a boundary of the network on the DMZ into a sinkhole where we archive the data. And of course, like everybody, we must cope with the GDPR. So what are our challenges? We, for go live, starting in January 2021, for us in the planning, this is basically tomorrow, we will have 8 million transactions peak per day, and these are small size messages of about 20 kilobytes each, remaining as generic as possible. And then the key questions were, how do we do this? How do we actually extract the messages from our running system, which is on the from the tapas, which is running on the DMZ, and put that into the archival system? And as you know, eArchival, the solution which is proposed, has two different out-of-the-box data extraction methods for databases, especially Oracle, which is generic and indexing per message, and extraction in a batch process. But this didn't sort of cut it, because we need to index every single message on the metadata. If we don't have the metadata index, we can't actually retrieve it. And so we had to basically rewrite the extraction method using PL/SQL. And so we've got the possibility to index every message and send that off to the actual ingester and into the archival nodes of eArchival. And we needed also to align this in the time frame and frequency domain with what our TAXUD access point for AS4 is doing, which is using the DG Digit supplied Domibus software, basically reference implementation of AS4 as a toolkit. So we do this once every 24 hours, and we then hope that we are able to extract all the message within 24 hours. Otherwise, we're in a bit of trouble. So we chose we considered writing our own solution for it. We thought we're going to do a small, lean and mean approach, and then we realized it will be possibly not that lean, but it will be quite mean. And so we also considered a commercial approach, and this will be, we thought, we've considered it, but it seemed to be quite expensive. So we chose in the end, we looked at what we had also in the building blocks in the CEF program, and then we saw that there was e-archiving with the RODA and SOLAR basically products, software products. So we had to do something that actually had our long-term, is able to do long-term preservation. We had done a proof of concept that is able to ingest 800 kilobyte records, 800 kilo records in 16 hours, and it was successful on our standard infrastructure, meaning low disks, slow disks, and not that performant machines. And we were reassured that the solution is scalable. We're not there yet by a long shot. We're still working on it. It's going to be a bit of a gamble to scale it up to to 8 million records, multiplying it by an order of magnitude, but we think it's achievable by doing a certain amount of optimizations, faster disks, horizontal scalability, and so forth. So we have done a first requirements communication to the Digit colleagues and to Keep Solutions in March of this year. We have done a proof of concept in May of this year with 800,000 messages per day in a one-node configuration. And then we were happy with that, and so we reached a go decision by June 2019 of this year, basically, because it was our best shot at actually finishing in a realistic time frame. So what are our requirements, basically? Little typo on the slide here. It's not 20 megabyte of message size. It's 20 kilobytes of message sizes. It's a simple one-node setup. We did a proof of concepts. Then we are doing a test coming up, basically, with a 3-node setup. That's going to be happening we're going to be starting configuring it soon, and then later on taking it live in the Q1, Q2 of this year. And then we are going to try to reproduce the 800K messages. And then later on, we're going to go into a production system at the end of next year, basically a year from now, where we actually need afterwards to prove that we're able to ingest that sort of message flow. So lots of messages, small size, everything has to be indexed. That's our challenge, really. And then we have optimization that we can do, addition of nodes and solid-state drives, basically. So we want to implement that as a shared service because we want it to be reusable for other sort of platforms, including the Common Communications Network 2nd edition for the logging and archival as well, as I just said. We have just finalized the contractual arrangements with Keep Solutions and our operations contractor as well, because we out-contract nearly everything at TAXUD. Then we are creating the environments for the ICS2 testing in development nowadays. And then later on, we'll do the ICS2 tests in March 2020. At the same time, we are also doing in parallel a container management platform, putting that into place. We are doing the deployment of RODA and indeed of these Solar clusters using Docker mechanisms. These Solar clusters come out of the box basically with a Docker swarm. Internally in TAXUD, we prefer Kubernetes because there seems to be more of a drive behind Kubernetes for Dockerization than for Docker Swarm. But we are happy to work with the existing solution as long as there is an upgrade path somewhere that appears on the horizon that in the end we can get rid of Docker Swarm. So we will, from February to December, work on putting into effect the archival in production. Then we'll do from October 2020 to January 2021 the ICS2 production, ICS2 being the Import Control System 2 requirements testing, and do test the 8 million of messages per day. And then in March 2021, hopefully magic happens and our ICS2 system, very ambitious, will be in production. And we have a separate team working on that ICS2 team, the ICS2 team working on this system by the same name. So there's just one takeaway for my particular and quite peculiar case. It's that we don't work with large images that we need to ingest and low number or medium number of messages. We work with a very high number of messages and very small messages that we need to index every one of them. And for that, we need to scale up and customize the system somewhat. And we chose for that the RODA and Solar system. So that takes me then to the end of my presentation.